Now that we've got everything installed and we've got Wireshark up and running, let's take a little walk through some of the absolute basics. So let's look at opening files, go over the layout of Wireshark, the typical 3-pane layout, and then we'll show you how to collect your first set of packets. Now, starting out, we see the Wireshark interface, and there's not a lot going on initially. We see there's some options to immediately start capturing some packets, and we'll do that in a minute. But first, I want to show you how to open an existing packet capture file. Within this course, most of the things you're going to work through are via packets that I've already captured for you via scenarios I've set up, either in a lab or something I've caught out in the wild that I want to be able to share with you for educational purposes in this course. Now, to open a file, it's pretty simple. It's like opening a file in any other application. I'm just going to click File, Open. And I'm going to, in this case, point to my desktop because here I have a folder called Packets. And it has a whole lot of packet capture files in it that we can use to just to play around with. And these are the same files that will be made available to you in the course here. Now, I'll go ahead and open up http_Google. That's just a packet capture of someone using the HTTP protocol to browse out to google.com and get the root directory of that web server. Now, when I open this up, you see that Wireshark automatically splits its view into 3 different windows. There's this window in the top here with this list, and there's this middle window, and there's the bottom window with these bytes. I'm going to go ahead and resize this a little bit, make it a little bit more appropriate for the amount of data being displayed. And let's talk about these 3 different windows. The top window is called the packet list window or the packet list pane. And it essentially contains a listing of every packet that's captured. In this case, we have 12 of them, and each packet is represented by an individual line. Now, the important thing to note here is as I scroll through these, you can see I'm on 5, and then I go to 6 and 7, is that the data below them in the second and third pane here is changing. Whatever packet you have selected up here in the packet list is what's reflected down below. So this is your area, your primary area for navigating and looking through things. Of course, the packet list displays a baseline set of information on its own, and that's going to be pretty consistent. These columns are static unless you decide to go in and change them, and we'll certainly look at methods of doing that later. But you see we have a number, so we're showing the order of the packets, and these are they're numbered in this case by the order in which they were received, so they're in sequence here. We have the time. We have the timestamp associated with the packet. There are a lot of different time formats you can use. We'll go through those in depth. Here we're looking at the time format where we start with 0, and every timestamp after that is time since 0. So we're getting progressively adding here as we go down. We have the source IP address and the destination IP address. The protocol used, in this case, the TCP and HTTP in this packet capture. We have the length, which is the size of the packet. And then we have an info column, which is kind of a catch-all that is used to basically show whatever information is relevant. And that's defined in the protocol dissector as to what data is shown here. So you see for our TCP packets, we're showing port numbers, source port to dest port. We're showing the TCP flags and some sequence numbers, acknowledgement numbers, things like that. For this HTTP packet here with an HTTP header on it, we're actually showing what the HTTP command was. In this case, it's a get for for slash, so the root directory, using HTTP version 1.1. Down below, you see it tells us the status code returned from the web server when the data that was requested is being delivered. So the info column is going to show you information relevant to whatever packet type Wireshark has detected that is being processed there. And that's really what's happening here, is Wireshark is taking this input packet data, it's parsing it through all of its various 1,000+ packet dissectors and determining, okay, this is a TCP packet, this is an HTTP packet, so on and so forth. And that's how it's determining how to display that information to you in the packet list window. Now that takes another step further when you look down here in the middle at the packet details window. And the packet details window, what's shown here is determined by what you click above. So if I click packet 1, I'm looking at details of packet 1. If I click packet 4, I'm looking at details of packet 4. and you'll see this packet contains a section for every protocol header that's present in the packet. So this is when we talk about encapsulation, and there's different protocols that work together to make a packet. They're organized kind of in that same way here. So we have an Ethernet header, and we have things we would expect to see in an Ethernet header, like a destination and source MAC address. We have an IP header, and we see things like the IP version and the header link that we expect to see there. And we even have things like the HTTP header, and we see HTTP information such as the host, user agent, and so on. So when you think about dissecting packets and how we did it in an earlier example by using our packet maps, that's really all the packet analyzer is doing as well, is it's essentially taking its own packet map, which is represented through C code and through protocol dissectors, and dissecting those out and placing those fields into a way that's much easier to visually interpret. After all, it's much easier to interpret HTTP information in this format than it is in raw binary or raw hex. And you actually see that data down here below in the third window. Now, the third window is the packet bytes window, and it's exactly what it looks like and what the name describes. It's the raw bytes, the raw data associated with that packet. On the left, we see the hexadecimal notation that we've already looked at, and on the right, we see the decoded ASCII notation where it's actually readable. So we actually see English readable text here. Now, not every packet type is going to have that. So if I switch to one of these TCP packets, there actually is no ASCII text. There's nothing that's really clearly human readable when it's converted over. So it looks like a bunch of gibberish. In this case, the hex is the same representation as we've seen before. But nonetheless, these three windows work together, and you'll find yourself using them a lot. When you're scanning for things and only need a baseline set of information, you're probably going to be looking at the packet list window. That's where you get an idea of what protocols are present, some basic information about what's going on, and so on. When you need to drill down further into a packet, you're going to dig down into the packet details, and you're going to expand specific headers, go down here and look at what you want to find. So in this case, if I wanted to look at what URL was requested in a GET request, I would click packet 4, which contains that GET request. I would expand my HTTP header, which is expanded here, and I would look and I would expand the GET request right here, and I see request method GET, request URI is / or the root directory. Now, don't worry about that too much. We'll talk about HTTP later, but you kind of get the idea. You start at a higher level of abstraction and then dig in further. If I were looking at some type of custom protocol or a protocol that wasn't fully dissected and I needed to dig even further than this, I could go down to the window below here, and I could even make it bigger if I wanted by clicking and dragging the divider here, and go in and actually look at these hex bytes and start trying to see what's going on there. Now, one of the cool things about this is if I click on an area as well within the packet details window, it's going to highlight the associated bytes, so it makes it really easy to navigate it. So if I wanted to know where the TCP dest port field is, I just click it and it's going to highlight it both in hex and in ASCII there. So I can see that data is easy to find. Same with source port or really with any other field. Sometimes when you do that, it's going to highlight really big chunks of data. The GET method might be small, but when I get to some of these other things like the host or the user agent, it's obviously a lot bigger chunk of data to deal with, so it's highlighting that for me as well. But the key takeaway here is that all these things are related, and you'll get more comfortable with the interaction between these things as you go along. Ultimately, the thing to remember is, starting at the top, you have the highest level of abstraction, so kind of your 10,000 foot view. And as you go down on the screen, you're honing in onto that really detailed, intricate view, almost to the point where you get to sort of the X-ray or inside internal raw data view here at the bottom. And that's really how Wireshark handles its layout. Now, this layout is customizable, and some people do some different things. This is what I like. I generally use this 3-pane layout because I teach a lot with it, and it's what's really applicable to most people, so it makes sense. I'll show you some reasons you might want to change that later on and show you how to do that. But for now, within this course, unless otherwise specified, we'll mostly be dealing with this same 3-pane standard layout. Now, without further ado, I want to go through and let's do our first actual live packet capture. We want to actually collect packets from the wire, and if you've done this before, this is going to be really trivial to you. But if you're brand new to Wireshark, this is really kind of a seminal moment in your packet analysis career, is capturing your first packet and trying to make sense of them. Now, you're not going to be able to make sense of them right now if you've never done any of this before. Don't definitely feel free to try, but don't feel discouraged if it seems like a lot of gibberish to you right now. That's okay. We'll get there. we'll make progress, but this is, every great journey begins with one step, and this is one great step for you, hopefully, is capturing your first packets. And I think you might be surprised by how easy it is. I've got Wireshark opened up here on my screen within Windows, and you'll see here under this capture heading, this is the main screen that's shown when you log into, or when you open up Wireshark. It shows your recently opened captures, and it shows your capture window here where you can proceed to capture new packets. Now, there's a Bluetooth adapter, and I'm not worried about that, but there's also this Ethernet adapter. And you see this little spark line here that shows some hills and valleys. That's actually network traffic as detected by your network interface. So it's seeing traffic right now. And if I want to capture data on this interface, I can just double click it. And what do you know? We have packets flowing in. Now, I'm on a network where there's really not a lot going on, so we see a lot of different things. We see some IPv6 traffic. We go down, we might see a few more other things, but nonetheless, I'm actually capturing packets right now, and that's all there is to it. And this will run continuously until either you run out of disk space or you stop it. And to stop it, I'm just going to click this little stop button right here at the top of the screen in this main toolbar, and you see if I hover over that, it says stop capturing packets. So I'm going to do that, and my packets are now ready to be to look at. Of course, I could have looked at them while they were capturing, but with the constant scrolling, that might not have been the best thing to do. But nonetheless, I can look at these now. Now, if I wanted to restart my packet capture back up, do it all over again, you see this little fin icon right here, the very leftmost icon in the menu. I can just click that, and that will start capturing packets again. I haven't saved this, so it'll prompt me if I want to save it. In this case, I don't. So I'll click that, and sure enough, we're capturing more packets. Another useful tip here is the restart button. So if I'm trying to capture a very specific scenario for whatever reason, and say I've missed it, maybe I started my capture too late, or I screwed something up, and I just want to stop and start the capture back without saving anything, I can just click this third button. This looks like a fin, a green fin with an arrow within it in the shape of a circle. And it says restart current capture. So I'm just going to click that, tell it I don't want to save the data, and back to the races. I'm capturing packets yet again. So the process of actually capturing packets, incredibly easy. You just pick the interface you want to capture from, and then you're ready to go. We can also change the interface. So if you have multiple ones and realize you've selected the wrong one, you can go in here under the capture heading and choose capture options. And we see there are different ones here. So at that point, I could click on one of these and click start, and it would allow me to start the capture in this way too. There are a lot of options here in terms of input and output related to packet capture, and we'll go over those here in just a little bit. But for now, know that that starting a packet capture is a pretty trivial thing to do, and these three icons up here will allow you to start, stop, and restart packet captures, really to your heart's desire. So hopefully you're being able to do your first packet capture. Again, don't be worried if there's some things in there that maybe don't make immediate sense to you. We'll hopefully get you there, but definitely also don't be afraid to dig in and definitely click around and look at different packets, click on them in the packet list window, see how that flows down to the packet details and packets bytes window, see if you can find some interesting fields, how they're related, look them up, things like that. It's a really good exercise, and packet analysis, as you'll find out, is one of those things where you honestly get better at it the more you do it, and hopefully through this course you'll continue to get better at it as well as through your own self-study. So that's going to bring us to the end of this lesson and the demos that we went through. Wireshark, of course, is the world's most popular packet sniffer, and that's for a lot of great reasons. First of all, it works on almost any platform. It's really easy to install and really easy to use. Very widely accepted, a really great support community. There's a lot of really good reasons to use Wireshark, which is why a lot of this class is built around it, and it's used as an analysis tool for general troubleshooting and troubleshooting network latency and troubleshooting security issues as well. The main Wireshark window consists of three main areas: the packet list, packet details, and packet bytes windows. And they all interact with each other and create a really nice flow that allows you to go from a 10,000 foot view all the way to a microscopic view of packet capture. So we installed Wireshark, and I showed you how to do that on Windows, and I showed you how to do that on Linux, specifically Ubuntu Linux. We used Wireshark once it was installed to open a capture file and look at the layout of Wireshark, and then we actually completed hopefully a milestone for you if you've never done it before, your first Wireshark packet capture, wherein we captured some packets and saw how those showed up in that 3-pane interface. So again, this lesson really meant for people who have never had any exposure to Wireshark. Very, very basic, very fundamental. But I wanted to give you the baseline of what you needed to really get up and going and get started for the rest of this course. As we go along, we're going to dig a lot further into Wireshark. We're going to cover virtually every configuration option, virtually every aspect of it, virtually every tool it provides for performing packet analysis. So buckle up, because it's going to get a lot more fun from here on.